my name is Alexandra Kulbaka. I'm a PhD student at the Imperial College London, and today I wanted to talk to you about building an engaging demo to showcase your research. So let's start with the typical research pipeline. So you start by doing lots and lots and lots of hard work, and the work pays off. You're getting really great results, you're really happy. So you write a paper about it, the paper gets published, then you publish the code on GitHub. Then you may even decide to share it with your network. So you may write a LinkedIn post or share it on some other social media platform. So the question is, why would you still want to do the demo? You've already done all this hard work. Why do I think that demo is still very useful to showcase your research? Well, I have three arguments. The first one is that I believe that demo really makes your research more impactful because it maximizes the outreach to your end users. So it allows clinicians or doctors to interact with the model that you build. It also appears to a larger audience because it's more engaging, so more people will interact with it than with, for example, a paper or with a GitHub code. And finally, it's more accessible for people with no background in machine learning, meaning that, again, you can showcase it to the clinicians, doctors, but also maybe the recruiters if you're applying for a job, or even your friends and family that you just want to show what you've been working on. So now that we know that building a demo is very useful, I also want to show you that it's not as difficult as you may think. And to do it, I've built a customizable web application that you can very easily adjust for your own model. And it can support different types of models, such as diffusions or segmentation models. It can be easily extended to support those models. But for this tutorial purposes, I'm going to focus on the classifier model. So, what do you need to build such an app? And you don't need much. You basically need a trained model file. I used PyTorch to save my model, so I have it as saved as .pt file. We need a Python classifier script that generates the prediction, and we need a few input images from your dataset. So to give you a high-level overview of what we're going to build, we basically need two sides. We need front-end that is user-facing, and we need the back-end that is going to generate the predictions. There are a lot of different tech stacks out there, a lot of different frameworks to choose from. For this tutorial purposes, I chose React just because it's very easy and intuitive to understand, even from people who haven't interacted with this framework before. It's very similar, it has similar tags to, for example, HTML that I'm sure many of you used before. And I chose Flask because it's a Python framework, therefore we don't need to worry about changing our Python script to, for example, JavaScript. So I chose those to really minimize the effort and build the application as efficiently as possible. So React is the user-facing side. User can interact with it, they can choose the data that they want to classify, and we have two options. We can either select images that are being already displayed on the screen, or a user can upload their own images. And once they select the image and ask the web application to classify it, React will send a request to our backend, so to our Flask server, with the image data, and then Flask will then send a we'll use the Python script for the classification that uses the trained model file to generate our disease class probabilities that will then be sent back to the React application, and the interface will immediately update to show the results to the user. So to give you more details on how the repository is organized, we have two main folders, backend and frontend. Frontend, again, is the React side, so we have the app.jsx, which is the main React component. We have some folders that are storing reusable UI components. We have components folder. We also have the assets folder that stores the sample images from our dataset. And we finally have the constant.js file that is the place for all the configuration constants, such as the API, URLs, and model info. But I'll talk about it more in a second. And then on the backend side, we have the main.py file that is Flask. It contains all the Flask API endpoints. We have the Docker file that is useful for deployment. We have the requirements file with all the Python dependencies, and we have the classifier folder with the get prediction function that gives us the classifier prediction results. So if you want to update the code to work with your own trained model, you essentially need to update the code in 4 different places. You need to update the model file. So you just replace the existing model file with your own trained model. You need to update the get prediction function. That's explained in more details in the README file with the examples on what the function should return, but it's also very straightforward. You're basically plugging in your classifier code to the file, just making sure that the results are being returned in the same in the correct format. And then on the front-end side, you need to upload your sample images to your asset folder and configure the constants file. And it contains model information such as model description, links to your GitHub or the paper, and it also contains the URL to your backend API once you deploy it. So again, it's very, very straightforward. It's not a lot of things to update. I try to minimize the amount of changes that needed to be made in order to make this web application to work with other models. So to run it locally, you need to first clone the repo, then open 2 different terminals, one for front and one for the backend, install the dependencies, or first create a virtual environment for the Python, and then just run the code. And frontend and backend will be running on different ports. So once you do this, again, explained in more details in the README file, but that's really what it is. Like, you're just running a few commands, and the application will be running locally on your device. However, if you want other people to interact with it, if you want to share a public URL to this web application, then you also need to deploy it. And you need to deploy frontend and backend separately. So there are many, many different hosting options out there. For this tutorial, I decided to go with Firebase hosting for the frontend and Google Cloud Run for the backend. And the main reasons I chose those options is because they are very easy to deploy. It's literally a few commands, as we're gonna see in a second. And they are also free, meaning at least if you, for example, exceed the number of calls to your APIs, you won't pay anything for it. The service won't work. So it's very safe options for the deployment that you won't need to pay anything for. So Main reasons, very straightforward to use and safe to interact with. And again, the deployment is explained in a lot of details in the README file, but just to show you that, again, it's not a lot of work. You first need to initialize both services, so the Google Cloud and the Firebase service, and then you just run the command to deploy both backend and the frontend. Backend will take some time. I think it took me like 15 minutes from start to finish to deploy the backend. Frontend should be done in like a minute or two. And once the processes are finished, you will also get the URL outputted in the console that you can just visit and interact with your backend and the frontend. So now that we downloaded the code, changed the code, and deployed the application, let's see how it actually looks like. So this is the demo, the little demo of the application. As we can see, it is hosted on the public URL, so you can just visit this site and it will be working. We are greeted with this page to choose what demo you want to see, either classifier or the medical diffusion. As I mentioned, the medical diffusion is not fully implemented yet. It only has the front-end side, but the classifier is fully working, so we're gonna see how it works on this example. We can see the title of the model and the model description. Then we have some links. We have links to the GitHub code and to your paper. Again, all of those information is configurable in that constant file. Then we have the panel to select an image for the classification. We can either select the image from the readily displayed images, and as we can see, the results are color-coded, so we can clearly see which is the highest prediction or which is like the likely prediction as well. Another option is for the user to upload their own image, and that's also configurable in the code. So if you don't want users to upload their own images, they don't need to do it. You can just disable that option in the config file, and this slider will just disappear. So users will only interact with the images displayed on the screen. Again, it works really quickly. You can replace the image, do like different prediction if you want to. And again, just to emphasize, both front-end and backend are being currently hosted on the cloud, so we can see that it is really quick and easy to interact with a website. And it is also responsive. So if you wanna see that website on your phone, it will also work really well, and users will be able to interact with it in any device they want. So that's it from me. Thank you very much for your attention. This is the QR code to the GitHub repository with all the code, and I'm really looking forward to seeing your new demos. Thank you very much.